Hey Tube, welcome back. Today we talk about data integrity in SQL database. So data integrity in SQL database, structured query language databases, or refers to the accuracy, consistency, and reliability of data stored in relational database. It is crucial for maintaining the correctness and the validity of the data throughout its life cycle. There are several key mechanisms and concepts in SQL databases that ensure data integrity, and we will talk about some of them. And in terms of system design interviews, you need to know them on high level. So the first thing that we'll talk about is the primary key. So we talk about the purpose and the implementation. So in terms of the purpose, ensure that each row in the database table is unique and identifiable. Okay. The implementation is that a primary key constraint is defined on one or more columns of a table. No two rows can have the same value in these columns, and primary key columns cannot contain null values. The other thing that also ensure that will be foreign keys. And we also want to talk about the purpose of the foreign keys. It's maintaining referential integrity by ensuring that relationships between tables remain consistent. You can think about the foreign key like you are pointing to another element in other table. Like the table has a row, and this row is pointing to another element in another table. The way that this implementation works, it will be like a foreign key is one table points to primary key in another table. Okay. So one table points to a primary key in another table. It ensures that the value in the foreign key column corresponds to an existing value in the reference primary key column. Number 3, we want to talk about the unique constraints. Okay, so the purpose of the unique constraints, the purpose first is that it's enforce specific rules on column values beyond their data type. The implementation, let me copy this. The implementation of the unique unique constraints is the purpose of it is that ensure that all values in a column or a group of columns are distinct. This is the unique constraints. Okay. The implementation, a unique constraint is defined on a column or a set of columns. No two rows in a table can have the same values in these columns. Okay. For example, if we have a users table, so no two user can have the same email, for example. The other thing that would be quite the same, which is the check constraints. Okay. For this one, let me copy this. No, let me copy the purpose only. And okay. For the check constraints, it enforces specific rules on the column values beyond their data type. The implementation, a check constraint is defined on column to specify a condition that each value in the column must satisfy. For example, a check constraint can limit values in an age column to be greater than 0. For example, we have also the not null constraints. The purpose of it is to ensure that a column cannot contain a null value, which is useful when a certain fields must have a valid data. The implementation. A not null constraint is applied to a column to ensure that data is always entered in that column for every row. We have also default values. It's the same. It's set default values for columns, and a value is not provided during data insertion. The implementation of it also, it will be the default constraint provided a fallback value for column when no explicit value is specified in an insert operation. We have another thing which is quite crucial, which is the transactional integrity, which is the asset properties. And I'll create a specific video about what are the asset properties, because it's an important topic to talk about in terms of system design. The purpose of it, it's ensure the reliability of transactions in database. Okay, the implementation of the transaction integrity or the asset properties. SQL databases use transactions which are a sequence of operations performed as a single logic unit of work. Transactions in SQL database followed ACID, which is atomicity, consistency, isolation, and durability properties to ensure data integrity even in the event of errors or system crashes. We have lastly the data restriction. The purpose of it is ensure that data stored in column follows a specific format, such as integer, data, or string. The implementation of it will be like when defining a table, each column is assigned a specified data type, which enforces the kind of data that can be stored in that column. So maintaining data integrity in SQL databases is essential for ensuring the validity and the quality of the data, supporting reliable data analysis, and upholding businesses rules and constraints. It follows. It also helps in preventing data errors and inconsistencies, which are crucial for the overall health of any data-driven application. So that's it for this video. I hope you like my content. If you like my content, subscribe and hit the notification bell so you'll never miss a video, and see you in future problem.